On July 14, 2015, a spacecraft the size of a grand piano flew past Pluto at over 30,000 miles per hour. It had traveled nearly 3 billion miles over 9.5 years. What it found changed everything we thought we knew about the edge of our solar system. The discovery of Pluto. Pluto was discovered because of a hunch. In the early 1900s, a wealthy astronomer from Boston named Percival Lowell believed there was a hidden planet beyond Neptune. He thought tiny wobbles in the orbits of Uranus and Neptune proved something massive was out there pulling on them. He built Lowell Observatory on Mars Hill in Flagstaff, Arizona specifically to find it. Lowell spent years searching but died in 1916 without ever locating his mysterious Planet X. His observatory, though, kept going. In 1929, a 23-year-old from a wheat farm near Burdett, Kansas named Clyde Tombaugh sent hand-drawn sketches of Mars and Jupiter to the observatory director Vesto Slipher. Tombaugh had made these drawings using a homemade 9-inch telescope. He had no college degree. Slipher hired him anyway. Tombaugh's job was to use a brand new 13-inch astrograph telescope and take photographs of the night sky. 2 shots of the same star field taken days or weeks apart. He would then load these into a blink comparator, a machine that rapidly flipped between the 2 images. If anything moved against the background stars, it would appear to jump back and forth. This was brutal, repetitive work. Each plate had to be carefully aligned in the blink comparator. Tombaugh had to visually scan through thousands of star images looking for the tiniest shift. He worked through freezing nights in an unheated dome at over 7,000 feet elevation, exposing hundreds of glass photographic plates, each one packed with tens of thousands of stars. Most plates showed nothing unusual. He kept going anyway. On January 23rd and January 29th, 1930, he photographed a faint dot in the constellation Gemini. On February 18th, 1930, around 4 in the afternoon, while blinking those 2 plates, he spotted it. The tiny point of light had shifted position exactly the way a planet beyond Neptune would. He'd found Planet X. Naming Pluto. The discovery was announced on March 13th, 1930, which happened to be Percival Lowell's birthday and also the anniversary of the discovery of Uranus. An 11-year-old British girl named Venetia Burney suggested the name Pluto after the Roman god of the underworld. Cold, dark, distant. It fit. Decades later, a small container of Tombaugh's ashes was placed aboard the New Horizons spacecraft, making him the only human whose remains have traveled beyond the solar system. The planet debate. For 76 years, every American kid learned Pluto was the 9th planet. Then, in 2006, the International Astronomical Union voted to reclassify it as a dwarf planet because it had not cleared its orbital neighborhood in the crowded Kuiper Belt. A lot of Americans pushed back hard. Polls showed strong public attachment to Pluto's planet status, and members of the New Horizon team still call it a planet. The reclassification actually made people more excited about the mission that was already on its way there. Pluto by the numbers. Here are some numbers to put Pluto in perspective. It's about 1,477 miles across at the equator, roughly half the width of the contiguous United States from New York to Los Angeles. That makes it 2/3 the diameter of our moon. Its mass is just 0.00218 times Earth's, about 1/6 the mass of the moon. Its average distance from the sun is 3.7 billion miles, 39 times farther than Earth. Sunlight takes 5.5 hours to reach Pluto, and at midday on the surface, the sun appears only 1/900th as bright as it does from Earth. That's still about 300 times brighter than a full moon here on Earth. Pluto's orbit is wildly stretched out and tilted compared to most planets. It swings from 30 to 49.3 astronomical units from the sun, and it actually crosses inside Neptune's orbit, which it did from 1979 to 1999. One Pluto year lasts 248 Earth years. It spins once every 6.4 Earth days, almost on its side, rotating east to west. Surface temperatures average around minus 387 degrees Fahrenheit, with extremes between minus 375 and minus 400. At those temperatures, nitrogen and methane ices become as hard as rock. The New Horizons mission. The mission to get there was called New Horizons. It was conceived in the late 1990s as the first mission in NASA's New Frontiers program. Earlier Pluto missions had been canceled because of budget issues and politics. In 2001, NASA approved a flyby mission led by Alan Stern from the Southwest Research Institute, with the spacecraft designed and operated by the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. The spacecraft weighed 1,054 pounds at launch and was powered by a radioisotope thermoelectric generator called an RTG that runs on plutonium-238, the same type of power source that kept the Voyager probes running for decades. The 7 instruments. It carried 7 scientific instruments, and the team gave them fun names. Lori was the high-resolution black and white camera for detailed surface maps. Ralph, named after the husband from the Honeymooners, handled color images and composition mapping using visible and infrared light. Alice studied the atmosphere with ultraviolet light. Rex measured gravity, atmospheric conditions, and temperature through radio signals. Swap and Pepsi detected particles from the solar wind and high-energy particles in the environment. And the Student Dust Counter, built by the University of Colorado students, measured dust in the Kuiper Belt. Launch and journey. New Horizons launched on January 19, 2006, from Cape Canaveral's Launch Complex 41 on top of an Atlas V rocket. It left Earth at 36,400 miles per hour relative to our planet, the fastest departure speed of any spacecraft ever at that time. In February 2007, it swung past Jupiter for a gravity assist that added another 9,000 miles per hour and cut 3 years off the trip. Most of the journey was spent in hibernation mode to save power, checking in once a week. Along the way, the spacecraft observed an asteroid in 2006, studied Jupiter's lightning and the volcanoes on its moon Io in 2007, and began snapping images of Pluto in early 2015 that already surpassed anything the Hubble Space Telescope had captured. The flyby. The final approach started in January 2015. By April, surface features were becoming visible. On July 4th, a computer glitch put the spacecraft into safe mode, and there was real concern the encounter might be compromised. Engineers recovered it in time. On July 14, 2015 at 11:49 Coordinated Universal Time, New Horizons flew 7,800 miles above Pluto's surface, closer than the distance from New York to Los Angeles, and 17,900 miles from its largest moon, Charon. The spacecraft was moving so fast the entire close encounter lasted only a few hours. It collected 50 gigabits of data, which then had to be transmitted back to Earth at a painfully slow rate of 1 to 2 kilobits per second. The full data transfer took 15 months, with the final bits arriving on October 25, 2016. The first confirmation signal reached Earth on July 15th after 22 hours of radio silence. During those 22 hours, no one on the team knew if the spacecraft had survived. It was flying through a region that could have contained debris or dust particles capable of destroying it at those speeds. When the signal finally came through, the team at the Applied Physics Laboratory erupted. President Obama called it a historic achievement. Alan Stern said the solar system saved the best for last, and then the science started pouring in. 10 discoveries from Pluto. Here are 10 discoveries from the flyby and the years of analysis that followed. Each one a reason Pluto turned out to be one of the most complex worlds we've ever explored. Number 10. The small moons are rapidly spinning ice balls that offer clues about how the Pluto system formed. Nix, Hydra, Kerberos, and Styx are all under 100 miles across. They tumble chaotically and are not tidally locked to Pluto the way our moon is locked to Earth. Their composition suggests they formed from debris after a giant impact, similar to how Earth's moon was created. Number 9. Charon's volcanic and tectonic past mirrors what we see on the other icy moons in the solar system. A smooth plain the size of California, called Vulcan Planitia, was flooded by ancient cryolava. The rugged terrain of Ozterra formed when a subsurface ocean froze and expanded, cracking the crust. A reddish stain on Charon's north pole comes from the methane gas that escaped Pluto's atmosphere and settled there, then was chemically altered by radiation. Number 8. The lack of small craters on both Pluto and Charon tells us something important about the Kuiper Belt. There are very few craters smaller than about a mile across. This means the Kuiper Belt has fewer small objects than scientists expected. That reshapes our understanding of how the outer solar system formed, suggesting gentler processes built these worlds rather than violent collisions. Kelsey Singer from the Southwest Research Institute pointed out that this gives us clues about how the entire solar system came together. Number 7. Dunes made of methane ice line the edge of Pluto's heart-shaped region. Hundreds of dunes stretch over 45 miles along the western margin of the area called Sputnik Planitia. Winds blowing off the glacier lift methane grains from nearby water ice mountains, and these grains settle into dune formations. In gravity 1/6 of Earth's and an atmosphere 100,000th as thick, dunes forming at all was a complete surprise. They appear to be geologically recent. Number 6. Convection cells churn the giant nitrogen glacier like a slow-motion lava lamp. The surface of Sputnik Planitia shows polygonal shapes about 10 miles wide, where warmer ice rises in the center and cooler ice sinks along the edges. These cells have no craters on them, which means the surface is geologically young. Computer models confirm this convection is actually happening right now, making Pluto the only known world with this kind of surface behavior at such extreme cold. Number 5. Glaciers made of nitrogen ice flow across Pluto today. These glaciers spill from the surrounding highlands down into Sputnik Planitia, carving channels as they move. In Pluto's weak gravity and thin atmosphere, they behave differently from glaciers on Earth. Blocks of denser water ice actually float on the nitrogen ice like icebergs. Pits, convection cells, and flow patterns are all visible. Seasonal cycles of sublimation, where ice turns directly into gas, drive this slow but continuous movement across billions of years. Number 4. Pluto has ice volcanoes. Features called Wright Mons and Picard Mons look like volcanic structures with central pits. Evidence shows that ammonia-rich ice flows flowed across regions called Viking Terra and Virgil Fosse less than 1 billion years ago, and possibly much more recently. These are cryovolcanoes, meaning they could erupt with cold materials like water, ammonia, and methane instead of molten rock. They reshape the surface without any heat source we typically associate with volcanism. Number 3. Pluto is still tectonically active because its subsurface ocean is slowly freezing. Water expands when it freezes, and as Pluto's underground ocean gradually turns to ice, it pushes outward, cracking the crust. This has produced fault lines hundreds of miles long and miles deep. Scientists have found no evidence of the surface contracting, only expanding. This means the freezing process is still going on, which means Pluto is still geologically alive. Number 2. A vast liquid water ocean almost certainly exists beneath Pluto's surface. Sputnik Planitia formed from a massive ancient impact that created a crater 500 to 100 kilometers across and weakened the crust above a subsurface ocean. That ocean, kept liquid by ammonia or leftover heat from Pluto's formation, pushed upward into the weakened area. The depth and shape of the basin, along with tectonic features surrounding it, all point to a layer of liquid water sitting between the rocky core and the icy surface. Pluto joins Europa, Enceladus, and Titan on the growing list of ocean worlds in our solar system. James Tuttle Keene from NASA's Jet Propulsion Laboratory called the finding astonishing. And number 1. Pluto's heart-shaped region drives practically everything happening on this world. The bright feature called Tombaugh Regio, named after its discoverer, is dominated by Sputnik Planitia, a basin roughly 600 miles wide filled with nitrogen ice at least 2.5 miles thick. This massive glacier acts as a cold trap, pulling in ices from the surrounding terrain and creating a mass imbalance on Pluto's surface. Combined with the gravitational pull of Charon, this imbalance caused something called true polar wander, which literally reoriented Pluto so the heart now faces permanently away from Charon. The cracks and faults we see across the surface are scars from this shift. The heart also controls Pluto's weather. Nitrogen ice sublimates during the day and condenses at night, generating winds up to 20 miles per hour that blow westward, opposite to Pluto's rotation. Planetary scientist Tanji Bertrand from NASA's Ames Research Center confirmed that Pluto's heart controls its entire atmospheric circulation. One geological feature, running the weather for an entire world. Pluto's atmosphere. Beyond the countdown, there's even more. Haze layers in Pluto's atmosphere extend more than 80 miles above the surface, far higher than anyone predicted. Pluto's atmosphere is 99% nitrogen with traces of methane and carbon monoxide. It's about 100,000 times thinner than Earth's, yet it reaches hundreds of miles into space because of Pluto's low gravity. The atmosphere expands when Pluto is closer to the Sun and collapses as it moves farther away, possibly snowing out entirely during the coldest parts of its 248-year orbit. James Webb Space Telescope discoveries. In 2025, data from the James Webb Space Telescope taken during observations in 2021 and 2023 confirmed something remarkable. Haze particles in Pluto's atmosphere strongly cool it by emitting mid-infrared radiation. Zhang from the University of California, Santa Cruz, showed that this process dominates Pluto's atmospheric energy balance in ways unlike any other known atmosphere in the solar system. Zhang described Pluto as sitting in a unique spot that gives researchers a chance to expand their understanding of how haze behaves in extreme environments. The James Webb Space Telescope also mapped the transfer of methane from Pluto to Charon's pole, where it turns reddish through chemical reactions triggered by solar radiation. Seasonal ice migration and global wind patterns all connect back to the activity of Sputnik Planitia, the heart-shaped glacier. These findings have implications beyond Pluto. They help scientists understand hazy atmospheres around exoplanets and even conditions on early Earth before oxygen filled our atmosphere, when hydrocarbon hazes may have played a role in prebiotic chemistry. Pluto's interior and moons. Pluto's interior is roughly 70% rock and 30% ice by mass, with a rocky core, a water ice mantle, and a surface covered in nitrogen, methane, and carbon monoxide ices sitting on top of water ice bedrock. Mountains on Pluto rise as high as 11,000 feet, and they're made of water and ice that's as hard as granite at these temperatures. The possible subsurface ocean sits 60 to 125 miles beneath the surface. Charon, discovered in 1978 by American astronomer James Christie, is half Pluto's diameter. The two orbit a common center of gravity that sits in the space between them, making them a true binary system. The four small moons, Styx, Nix, Kerberos, and Hydra, are all irregular, fast-spinning, and rich in water ice, likely fragments from the same giant impact that formed Charon. New Horizons today and the future. New Horizons is still operating. It passed 60 astronomical units from the Sun in 2024 and has enough power to continue collecting data into the 2030s. It's currently measuring the hydrogen wall at the boundary of the solar system, along with dust and plasma between stars. On January 1, 2019, it flew past Arrokoth, a small Kuiper Belt object 4 billion miles from the Sun, making it the most distant close flyby ever conducted. Arrokoth turned out to be a reddish, two-lobed contact binary, two smaller objects that gently merged over time rather than violently colliding. That discovery reshaped theories about how the building blocks of planets form in the outer solar system, pointing toward a process called streaming pebble accretion, where small particles gradually clump together. Scientists at the Applied Physics Laboratory and the Southwest Research Institute continue analyzing the data. There are proposals for a future Pluto orbiter, possibly even a lander equipped with a small helicopter drone designed for Pluto's thin atmosphere. Funding remains the biggest obstacle. New Horizons may be able to target another Kuiper Belt object before it exits the belt around 2028 or 2029. Pluto in American culture. Pluto's been a part of American culture since the day it was discovered. Disney named its famous cartoon dog Pluto in 1930, the same year Tombaugh found the real thing. After the 2006 reclassification, campaigns to restore Pluto's planet status popped up across the country. The New Horizons flyby was a national event. Millions of Americans watched live. Schools held Pluto Day celebrations, and the images dominated every news cycle for weeks. A Kansas farm kid discovered it. A Florida launch sent the probe. A Maryland team built the spacecraft. Colorado led the science. The ashes of the discoverer rode along for the journey.